Hi, this is about how to make a Pico balloon tracker using an Arduino. And my focus for this was students. If you go to any maker fair, you'll see dozens of students programming Arduinos to get their robot arms to move. So this is the right architecture for students. Now, if my focus is students, it also has to be very inexpensive, and also the technology has to be through-hole, because surface mount devices, surface mount soldering requires a lot of extra skills that are probably a little bit too much. Now the third requirement I had was I wanted it to be extensible. I wanted to be able to integrate additional sensors into the tracker so that a science fair project could integrate a sensor and fly it around the world and take data all the way around the world. All right, so this is the parts for the tracker. There's only 3 parts. There's a GPS board, which is made for Arduinos, and that provides 3 things. It provides accurate time, it provides accurate position, and it also provides a calibration signal for the Si5351 transmitter board. The Arduino is an Arduino Pro Mini 3 volt, and the transmitter board is the Si5351. Now all 3 parts are available on Amazon. One off, the GPS is $9. If you look around, maybe on eBay or other places, you can get the same one for about $6 in small quantities. The Arduino board is about $10, one off. If you look around in quantities, you can get them for about $5. And then the Si5351 costs about $8. So if you're only going to make one, the total cost for the transmitter is about $30. If you want to make more than one, it's down around $20. Now, because there's no USB interface on the Arduino, you need a USB to serial interface, and instructions are included on how to connect that together. Okay, so these are the wires you have to put together, but if you're a high school student, you need more than just a wiring diagram. You need to know how to connect up the serial to USB connector, and what are the things I need to look for. So I've created extensive documentation. It's very detailed documentation. It goes step by step. It's not put it all together, see if it smokes, but it goes step by step. First of all, you download the software, you connect up the serial port, and you download the software onto the Arduino, make sure the software is loaded properly. Then you connect up the transmitter board and make sure the transmitter works properly. Then you connect up the GPS device and you do a complete system test. And like I said, there's a lot of documentation. There's a 25-page document. Now there's all kinds of pictures on how to do this, that, and all the different steps in putting it together. Now that detailed document is on my website, and my website contains a lot of information. It contains the best information I know on how to put together a package that will go around the world. And as I see people on the website, on the web, talking about really good ways of doing things, I add those comments to my website. So you may want to take a look through, especially if you're new to this. This will bring you up to speed on what to do and how to do it. Okay, so when you're done, you'll have a tracker that weighs about 7.6 grams, and a nickel weighs 5 grams. So it's quite light. It's heavier, much heavier, significantly heavier than a single custom-made board that only does tracking. But this works quite well. Okay, since I've been doing, and this is what it looks like. This is the finished product. Now the wires, the black wires going off to the side, those are removed because those are the wires used to download the software from the computer onto the Arduino. But it's a relatively small package, and it's proven itself. Since I've been doing this since 2019, I've flown 6 balloons using this system, and it's worked every time. No issues. Now the balloons up till a couple of years ago were pretty poor, and you were lucky to get a couple, 3 days out of them. But on those couple 3 days, the system worked just perfectly. Now, in the last couple of years, they came up with some new balloons that you could almost be sure about going around the world as long as you've filled the balloon, stretched it properly, and put a good seal on it. In the upper right corner is a balloon that went around the world 3 times in 60 days. I launched it last July. And down in the lower left corner is a balloon that was up for 120 days. It went around the world 6 3/4 times. And then the last we heard of it was off the coast of Alaska. Now this was in the wintertime, so the solar collector had trouble collecting enough sun when it went into the north. So after this day, after the February 10th, we didn't expect to hear from it for quite a while. In fact, we didn't hear from it for the whole month of January, and then in the beginning of February it started transmitting again. But again, it was in the quiet, but it was predicted to go along that red path. Now, on February 11th, the next day, there was a reported takedown by some airplanes over the Yukon. Now, in order for those fighters to take down the balloon, President Biden had to call President Trudeau to get permission for the planes to go over the Yukon. So the United States sent up 2 fighter jets and a refueling plane, and the Canadians sent up two planes and the Royal Canadian Mounted Police to do a search. I would love to be a fly on the wall when they told Biden that that balloon was probably sent up by a 73-year-old grandfather. Okay, so the last requirement is to prove that this is actually extensible. And Stephen Rector, NU7B, has proven that. He's taken my design and built it and added on a custom gamma ray detector that he's designed, and he's flown it around the world a few times already. He's added on a couple balloons, and it worked. He was able to go into my software and make the modifications required. Now, it's more than just adding a new sensor and getting the sensor to give you data, because you have to get the data down somehow. So if you're familiar, or this is the way we typically ballooners get data, there's a standard message, standard whisper message, and it contains your call sign, a 4-character grid square, and an indicator of the power. Now, we ballooners co-opt that, and we send down a second message following the first message, and it contains information like the temperature, the number of satellites, the voltage, and extra characters to make it a 6-character position. But you can see it's encoded. That call sign is actually for a fictitious country. There's no country that has a O in the first position and a 7 in the third position. The other characters are encoded information. And it's not just character. It's not uppercase or lowercase. The last 3 characters can only be capital letters, so there can only be 26 different values. The R can only be one of 36 values. It could be a number or a letter. And so we need to take the data that we collect from the sensor and get it into these funny numbers and letters so that we can download it through the Whisper processing system. So to do that, we need to create a custom telemetry message. Okay, so with 50 years of software development experience, I've tried to make this as simple as possible. I've made it into layers. First, you get the data. So there's a file called customsensors.h, and this is not object-oriented. This is straight C code to make it easy. Customsensors.h, all that does, it has responsibility for interacting with the sensors and getting the data and storing it. Okay, the next layer is a bunch of utilities that take the actual data and convert it into the funny numbers and letters needed for the custom transmission. Then the next layer down from that is the code telemetry message.h, And that takes the funny letters and everything and formats it into the actual whisper message that's going to be sent. Okay, and then there's a fourth layer, that's send messages.h, and that waits for the proper time and sends out the message. Okay. All right, so people have tried this before, or people have thought about you doing this before, and they've not done it because they've found that these transmitter boards will actually drift a little bit. And they will. If you're using this outside in the wind, and there's a very strong wind, the frequency would maybe drift more than the 4 hertz allowed for a standard message. But when you're up at altitude, you don't have that issue because the balloon travels at the speed of the wind around it. So there's very little wind actually relative to the actual tracker, and that's why it works fine at altitude. So one thing you might be able to do is to put a little piece of foam on the crystal. It's a little metal box that should help, but I've done it both ways and it works both ways, with or without the foam. You also will have a problem as you ascend. So as the balloon goes up to altitude, you may not get any transmissions until it gets to full altitude. Okay, so these are 2 manufacturers that I recommend. Both of them are available on Amazon. I've tried many others, and they've all worked except for one. The one that didn't work had a plastic case on the crystal, and it would drift so bad that I couldn't even in my laboratory with no wind at all get a good signal. But all of the ones I've tried work. I recommend these manufacturers. Okay, last. What's next? Where am I going? Well, I'm in the process of replacing the Pro Mini with a Arduino board. This is a very, very small Arduino board. It has a much more powerful processor, and we'll probably be able to do more things with the sensors using something like this than with the smaller board. Also, I'm looking at using a different Si5351 version, and this potentially will provide APRS as well as Whisper, and then you'd be able to download significantly more data than you'd be able to using just Whisper alone. Okay. So if you have any questions, send me an email. I'd be very happy to answer. Also, this is my URL for the website that has information, and I wish you a lot of luck. See ya.